Hi everybody, Ms. Wombold here. I hope we're all being our best, most amazing selves. Today we're going to be talking about representing inequalities. We talked about inequalities a little bit with domain and range, but we haven't talked about them much else since middle school. So we're going to review it today. So first, remember that an inequality is a comparison between two values. If our inequality is opening in this direction, we're always going to have our smaller number on the left and our larger number on our right. Remember, we think about the crocodile wants to always eat the larger number. Now, if our inequality was opening the opposite direction, we would switch the position of the larger and the smaller. Just keep in mind, it's always opening towards the larger number, no matter which direction it's opening. Something else to keep in mind with inequalities is that there are two types of inequalities. So the first type of inequality is called an exclusive inequality. An exclusive inequality. And we call it exclusive because it doesn't include the associated value. It does not include the associated value. So for instance, it's either going to be less than, like this symbol here, or it's going to be greater than. There is no equal sign involved. It excludes, it is exclusive. If it does have an equal sign, we call it an inclusive inequality. So here we see the equal signs, and what that means is that our inequality does include the associated value. So, if we were to see this inequality, maybe in an example like this, we would read this as x is less than or equal to 10, because it's opening towards the larger value, so 10 must be larger than x. On the flip side, if we saw something like this, right, where it's opening the opposite direction, it's still got that equal sign, we might say x is greater than or equal to 7. So knowing whether you've got an equal sign or not tells us whether it's exclusive or inclusive, and that's going to be important in a couple minutes. We'll come back to that. Intervals with inequalities, we should remember this a little bit from domain and range, but this is the kind of statement where we say x is between two numbers. So if we see it written something like this, maybe we've got some different exclusive and inclusive inequalities. Either way, x is in the middle. We've got a smaller number over here, a larger number over here. So we've got an interval, and this should look familiar again from domain and range. Now, number lines. This is how we really start to represent inequalities here, is with a number line. And there are two things to keep in mind. First, we should notice that we've got arrows pointing in different directions. We should also notice that we've got different kinds of points. Now, we definitely talked about those types of points with domain and range, but let's review them here. We've got open circles. Open circles are our exclusive inequalities. Whereas our closed circles are our inclusive inequalities. So, for instance, if we look at the first example here, we've got an open circle directly above -6, which means we've got x and -6 somehow involved, and we know, since it's an open circle, that there is no equal sign. Now, since the arrow is pointing to the values that are bigger than negative 6, we know all these numbers are larger than negative 6, we're going to say x is greater than negative 6. And it's going to open towards x with no equal sign. X is greater than negative 6. So what this means is if we've got an open circle opening to the, or with our arrow pointing to the right, excuse me, that means we're going to use the greater than symbol, or the greater than inequality. It's exclusive, greater than. We might also have an open circle with the arrow pointing to the left. That means we have flipped the inequality. We're still exclusive, but this time we're going to say less than. In our second example, we've got a closed circle, so now we're kind of in the inclusive range, and this time our arrow is opening, or pointing, excuse me, to the left. So our closed circle is right above 4, so we know we've got x and 4 involved. We know that it's an inclusive inequality, so there's going to be an equal sign. And then we think about, how do these values relate to 4? Well, they're all smaller than 4, so x must be less than or equal to 4. So we're going to write that in English here. X is less than or equal to 4. So we're going to make a note about our closed circles the same way. If we have a closed circle opening to the right, we're going to use the greater than or equal to symbol. Greater than or equal to. And if we have the case like we do right here, it's a closed circle with the arrow pointing to the left. We switch that inequality and we say this is less than or equal to. This third example here, we don't have arrows, which means we're stopped. There are end points. This is an interval. So let's first look at where the interval is. So it's at its lowest, it's at -3. At its largest, it is 7. So I'm going to write -3, x, 7. We know that our inequalities are going to be opening towards the larger numbers. So our inequalities are going to be opening towards the larger numbers. And then finally, I have to consider, what type of points do we have? We've got one closed and one open, which means our inequalities, one must be inclusive and the other one stays exclusive. So we just have to keep that in mind. And then in English, we might say x is between -3 and 7. So all these things to remember. Is it inclusive or exclusive? That tells us what kind of circle to use, and then what direction does our number line go? Are we above that value or are we less than that value? And then finally, if we have an interval, how is our interval enclosed? So we're going to do some examples of that on the next page, page 15. If you need to pause now and go back and fill in some of the notes on page 14, if I went a little fast for you, please go back and do that. Otherwise, we're going to meet on page 15 to fill in just a couple of examples here. So first, we've got the statement x is less than 8. So we're going to translate that to x is less than 8. There's no equal sign. It's opening towards the larger number. X is smaller than 8, so it's opening away from it. And then on our number line, this is exclusive. So I'm going to put an open circle right above 8. And if we're talking about the values less than 8, we're talking about the values to the left. So I'm just going to make my arrow obviously pointing to the left. Some people choose to put their circles and their arrows right on the number line. I like to do it above so that I can see the difference. Second example here, x is greater than or equal to 0. So this time, x is greater than, so it's going to open towards x, and it's got that equal sign, so I want to include that, and 0. So on my number line, I'm going to put a closed circle at 0, make it obvious, and then since we're talking about the values that are larger than 0, our arrow is going to point to the right. And last but not least in this section of the examples, if x is between or equal to -10 and 10, that means we've got an interval here with the smaller number on the left, the larger number on the right. And when we put our inequalities in here, we want to make sure that they are inclusive, that they've both got that equal sign. And then when we make our number line, closed circles, not open circles, not arrows, and everything in between. The second set of examples, we're given the inequality in the algebraic notation here, right? But we have to translate it into English and then translate it into a number line. So for this one, we've got an interval, right? -6 on one side, 2 on the other, x is between them. But notice they're both exclusive. So we say x is between but not equal to -6 and 2. So we know it's between them, but we also want to make a note that it's not equal to either of them. There's no equal sign there. And then when we make our number line, we've got open circles on either end. Make it very obvious, no arrows, and then a segment in between. I'm going to do one more in this section and then one more in the next section until we get the hang of it. So we've got x, we've got the inequality opening towards -1, which means that x must be the smaller value. So we're going to say x is less than or equal to -1. So when I put this, I look for -1, I put my closed circle, and I'm going to open to the left because those are all the values less than -1. For all these ones down here, the main goal is to first figure out, okay, what value is involved. So if we look at this first example, we've got 4 involved, so we know x and 4. Our arrow is pointing to the right. It's all the values that are bigger than 4, so x must be the greater value. And there's no equal sign here. There's no closed circle, no equal sign. Cool, done. All I have to do is translate it into English. X is greater than 4. The only odd one here, if we look at this third example in this section, there's no dots at all. And we know from previous experience that these arrows will go on forever and ever and ever. And if we zoom out, eventually we'll hit -infinity on one side, +infinity on the other. So our inequality might look like this. We don't want to use equal signs here. We want it to be exclusive because infinity is not really a true number. It's more of a concept of a very, very large number. And then if you remember the phrase we used to represent this, it was all real numbers. So I'm going to leave you here, but what I am going to do is I'm going to leave the rest of these notes in Module 4 so that you can fill in the rest of these notes and then get started on your practice assignment. If you have any questions, please ask your guest teacher, Miss Bodner. She knows what she's doing. Have a great rest of your day, folks.